A very good day to all the participants. Today we are going to discuss about the pulverizer plant and milling system, which are one of the essential boiler auxiliaries to burn the fuel after processing in this plant for effective steam generation. In the solid fuel firing system, particularly for coal firing, it can be done by two methods, either firing in a bed, which is underbed firing, where we can have stoker firing arrangement, travelling rate or static stoker firing arrangement, and mostly present day boilers which are of high capacity, they use suspension firing. That means fuel particles are burned under suspended condition, so pneumatically conveyed in the furnace and then burned in the suspended condition, and that's why it evolved in pulverized coal firing. As we go for pulverizing the coal, the basic improvement in the firing system is that the pulverized coal is having more surface area, so we have better drying of the coal, which is hygroscopic in nature, and we can burn it more quicker, and it is having better heat releasing rate. So process of pulverizing gives us the opportunity to utilize this solid fuel to use just like a gas, so that we can have a better grip and control over the rate of firing within the furnace, and to control the heat release rate. From the perspective of input and output of the pulverizing process, the inputs are basically through raw coal feeder, from which we are supplying the raw coal. In fact, the raw coal is already having certain amount of moisture and incombustible as an inherent component of the raw coal, and when it is supplied within the pulverizer to for grinding, along with that we are supplying hot primary air along with tempering air, or sometimes we also supply some amount of flue gas as a part of heating agent. So this primary air is coming for drying and helping in flying the coal to convey pneumatically to the burner in suspended condition. So during the process of pulverizing, we get the ground coal. So output of the pulverizer is definitely pulverized coal plus air. Then the moisture is separated, that is also carried by this air, and there are some rejects coming out of the milling system, which are non-coal particles and which cannot be ground. Therefore, the basic features of pulverizing system constitute feeding of raw coal through a coal feeder, which is taking the coal from a raw coal bunker where it is stored, then pulverizing the coal in the pulverizer or mill, then removing the moisture of coal so that coal can be dried and ready to pneumatically convey in the burners through a coal carrier pipe. Then during the process of pulverizing and circulation, there is classification of coal according to size, so that only specified size of the coal particles can go to the furnace for burning, and there is transporting the pulverized coal. Let us now focus on raw coal feeders or RC feeders. As you know that raw coal feeders are feeding raw coal from bunkers to mill according to the coal quality, boiler load and mill conditions. And as you see, when the load is increased, the quantity of coal flow must be increased. If the coal quality is low, the feeding must be increased further. If the coal quality is high, feeding is reduced. Again, when boiler load is less, naturally coal feeding has to be reduced, and when boiler load is more, we have to increase the coal feeding. So naturally we find depending upon the coal quality and boiler load, coal feeding is varied by the coal feeder. Beside that, in terms of mill condition, when mill cannot grind the coal sufficiently, then also we have to restrict the coal flow, and that is done by coal feeders. The RC feeder classification is basically done on mode of feed rate calculation. The feeding rate may be calculated with respect to volume or with respect to mass of the coal. For volumetric coal feeding arrangement, the rate of coal flow is calculated based on bulk density, volume per rotation of the coal feeder, and speed in meter per second of the coal feeder belt. And in case of gravimetric feeding, the rate of coal flow is calculated by mass per unit length of the belt, mass of coal, multiplied by speed of the belt in meter per second. In this slide, we are seeing scrapper feeder or drag link chain feeder. In this type of feeder, the flow is volumetrically quantified. That means when the chain is moving by a sprocket in the driving end, then coal is dragged from intake position to the discharge position, and as the coal is flowing, it is volumetrically measured and it is flowing to the mill. This one is a rotary volumetric coal feeder, where this rotary feed roll is feeding the coal from the raw coal bunker to the coal mill, and this feed roll is rotated by a sprocket. Sprocket is attached with a chain, and then this chain is attached to another driving sprocket attached to PIV gearbox and a Redicon gearbox that is attached to through a shaft to the motor. So this way we are having the feeding of coal through a rotary volumetric feeder. Inside the rotary volumetric feeder, we have a feed roll assembly. In this feed roll assembly, the feeder is attached with a spider assembly and blades are there. So this is rotating over the main feed roll support barrel, and the shaft is coming from the inner side of the barrel, which is rotating this feed roll blade and spider assembly. Hot air is supplied through the main barrel so that there is no sticking of coal particles if it is wet. When the coal feeder is not running, the coal particles may stick on this surface and that may create trouble to run it again. Gravimetric coal feeders are belt driven coal feeders. They have two pulleys, one is take up pulley, another is head pulley, and across this pulley belt is running, and there is a belt tensioning arrangement. We are also having no coal flow signaling, and the coal is dropping on the belt at the take up pulley zone, and they are having load cells which are sensing the coal quantity on the belt, and they are sending the signal about the quantity of flow. There is RPM measuring device at the head pulley, and there is also sensors which are integrating the coal flow quantities. Depending upon the weighing arrangement, gravimetric feeders may be mechanical weighing type or electronic weighing type. In case of electronic weighing type, we have two arrangements, either constant load on belt type of arrangement or varying load on belt type of arrangement. In the electrical weighing arrangement, we have load cells fitted at the bottom of the belt, and that is measuring the weight, instantaneous weight on belt, and that is also getting reference with the RPM, not RPM, revolution per second, and that speed and weight, when that is multiplied, that is giving a feeding rate to the combustion control, that is matching with the demand actually, and that is giving the demand, and that demand is compared with the feed rate, and feed rate from all the coal feeders are integrated together through a totalizer, and from there a feed rate error signal is generated, and this error signal gives signal to the RPM, speed of the coal feeder for correction, and subsequently the speed is corrected. Let us see the gravimetric feeder internal arrangement now. In the gravimetric feeder, we have two pulleys. One pulley is actually attached to the driving arrangement, and tail pulley is non-driving arrangement, and these pulleys are actually running the belt, and there is a tensioning pulley that is giving the belt tension. Even with the belt tension, there is some certain amount of slippage, around 2 to 3% slippage is there. There is a belt travel sensor which is sensing the rotation per second, and there is a clutch to quickly stop the belt in case of no coal flow. There are load cells which are sensing the quantity of coal available in the belt per meter length, say, and there is a coal feeder intake piping which is providing the coal feeding into the coal feeder from the raw coal bunker, and beside that we have AC motor which is driving the coal feeder, and this there is a dyno drive arrangement that is varying the speed speed in meter per second, in which we control the flow of coal into the pulverizer. In rotary volumetric feeder, where speed control is not done by thyristor control or dyno drive, we have different arrangement where a PIV drive is used. In this kind of arrangement, feeder is attached to a chain sprocket arrangement. The non-driving end sprocket is attached to the feeder, and driving end sprocket is attached to the speed reduction gearbox. This gearbox is attached to PIV drive. PIV drive is nothing but a positively infinitely variable drive where the speed is changing steplessly, and in the PIV we are having two sets of your chain, gears, and these gears are bevel gears actually. These gears are attached to each connected to each other by a frame, and this frame is pivoted in such a way it can tilt, and there is a chain, PIV chain, which is running over this set of bevel gears, and when there is a requirement of change of speed, that with respect to pivot point, the shifting of position of these bevel gears are changed. As a result, the PIV chain in contact of the bevel gears, their contact diameter changes, so naturally speed is getting changed. These PIV chains are made of fine strips of metals which can steplessly change the speed with their adjustment to the bevel positions with respect to each other. So this way speed reduction takes place through the PIV, and from the PIV this connection is given to the motor. So when motor is running, so it is giving the torque to the PIV, from PIV to speed reduction gearbox, from there to driving sprocket, from there to driven sprocket, from there the coal feeder. This way it is going on. Now we are going to discuss about the pulverizers. Pulverizing is a combination of three physical processes: impact, attrition and crushing. As you know, impact is the sudden surge force through which fragmentation takes place, and attrition is the due to the frictional resistance. When the similar particles are getting in contact with each other, they are getting fragmented. That is due to attrition. Just like two chalks you are taking and you are rubbing each other, they are getting fragmented. And crushing is this continuous rolling load, as a result of which substances are getting crushed into smaller fragment. So this way, these three physical processes are incorporated for pulverizing. The basic functions, those are served by pulverizers, are grinding of coal to the fine micronized size, then drying of coal, rejecting undesirable rejects, non-coal particles like pyrites and stones out of pulverizer, and transporting the pulverized coal after due classification as per size, and sending them to coal burners for firing in the furnace. According to operating speed, we find three categories of pulverizers. At the low speed, within 10 to 20 rpm, we have ball tube mills. Then medium speed, 40 to 70 rpm, we find bowl mill, MPS mills, ball and race mills, and some of the mills, they are running at very high rpm, 900 to 1000 rpm, like hammer mills, beater mills or fan mills, which are used for lignite firing. Let us see what are the major types of mills. The majority of the boilers of large capacity units, they are having tube or drum mills or ball tube mills. These are low speed mills, those who are used to grind coal with steel balls inside a rotating horizontal cylinder, and if the diameter of the cylinder is greater than the length of the cylinder, this type of mill is called drum mill, and if the length of the cylinder is greater than the diameter of the cylinder, it is called ball tube mill. In case of vertical spindle mill, we have medium speed mills like bowl mill or ball and race mill. Bowl mills may be deep bowl mills or shallow bowl mills like MPS mills. In case of high speed milling arrangement, we have impact type milling system like bitter mills or crusher mills. They are used as high speed. In case of ball tube mill, we are having a cylinder. Within this cylinder, we are having different steel balls of different size, starting from 50 millimeter to 30 millimeter. And when this cylinder is rotated, then along with that, these steel balls are rotating, and we introduce the coal. And this coal, when it is introduced, due to impact and crushing, mostly impact and crushing load is there to pulverize the coal, and the coal is getting pulverized. Actually, this cylinder surface, internal surface is fitted with wire plates, and in these wire plates and ball there is continuous friction. Due to this friction, crushing and attrition is taking place. Now, this pulverized coal along with the hot PA supplied inside the drum or tube mill, that is being taken out and sent to a classified zone. And in the classified zone, it is getting classified according to size of the pulverized coal particles. Heavier coal particles are getting returned through a return coal chute to the coal feeding arrangement within the mill, and lighter, smaller particles, coal particles, those are moving through towards the coal carrier pipe. We have arrangement to supply bypass air, that is part of primary air, to improve the classification, and there is screw conveyor arrangement which is rotating continuously to feed the coal within the milling system. This type of milling system operates in a temperature of 95 to 100 degree maximum, because if the the mill outlet temperature of the coal particles and primary air is not above 90 degrees centigrade, and inlet primary air availability, it is around 340 to 320 degrees centigrade. Beside that, this type of milling system, as you see, there is no rejection arrangement, and if the moisture is high in the coal, there may be a problem of drying, because this type of mill cannot handle coal wetness more than 7 to 10%. If coal wetness, moisture content is more than 10%, then we have to reduce the capacity utilization of this mill, as the PA fan flow is limited with the drying capacity. So this way, these mills are utilized for pulverizing the coal and supplying the pulverized coal to the furnace for appropriate utilization for steam generation. Now we will discuss about shallow bowl mill, where you have rollers and bowl to get the grinding arrangement. Actually, this type of milling systems are having capacity of milling from 25 tons per hour to say 50 tons per hour. For higher capacity milling, we use ball tube mills or drum mills. For medium capacity milling, we use bowl mill. They are rotating at a speed of 40 to 100 rpm maximum, and here we have milling system where coal is coming through the central coal inlet piping through the classifier, and it is falling on the roller zone. Here bowl is rotating at a specified rpm. It may be 40 to 90 rpm, and as the bowl rolling, then above it there are three rollers. These rollers are placed 120-degree apart, and they are not in contact, but whenever coal falls on the bowl, this coal is trying to get spread across the bowl, and they come in contact between bowl and the roller, so they get ground and pulverized, and this pulverized coal is moving up after drying towards the classifier. When the primary air is coming from the bottom of the bowl, in the bottom of the bowl there is scrapper zone. Whatever non-coal particles are there, say pyrite or tramp iron, they fall away from the bowl due to centrifugal force within the rejection zone, and scrappers are used to remove this through the rejection spout. There is a gearbox fitted with the vertical shaft. This vertical shaft is attached to the bowl, and thereby it is rotating the bowl, and this gearbox arrangement is such that it is attached to the driving end is attached to a motor, and there is a bevel gear, and this bevel gear with the pinion, it is rotating the vertical shaft. An entire gearbox is filled with lubricating oil, so that it can be lubricated all the bearings. The bowl mills are generally maybe suction type or pressurized type. Mostly pressurized types are used. Their nomenclature may be as XRP or SRP. XRP means 3-phase 50 Hz supply, Y for 60 Hz supply, R means Raymond, P is pressurized, S is for suction type arrangement, and nominal diameter, pitch circle diameter of the bowl contact area, that is also in the nomenclature, and number of grinding rolls are specified in the nomenclature. So XRP 803 implies the nominal diameter of the bowl is 80 inch, and last digit 3 implies 3 numbers of grinding roll. So this way nomenclature is made. A bit detailed discussion on the constructional features. If we see that the motor is 6.6 kV 3-phase induction motor is there in general. These are actually vertically placed milling system, and this motor is rotating the worm gear in the gearbox. Worm wheel is there, and as a result of rotation the vertical shaft is rotating the bowl. Now above the bowl we have 3 rollers placed. There is a roll journal assembly, and they are actually loaded with some journal spring assembly, which are giving the pressure, so that within the mill there is some pressure available for coal grinding, and when primary air is coming inside through the gap between the bowl and the mill body, there are several mill body liners, around 8 kinds of mill body liners are there. They are creating the swirl, and due to this swirl, coal particles which are getting pulverized, they are moving upward, and through the classifier cone they are entering within the classifier cone, and there is a vortex formation. Due to this vortex, heavier particles comes down across the classifier bottom zone, and along with the coal feeding discharge line that is falling in the bowl again for recirculation, and smaller particles through the turret they are moving towards the pulverized coal carrier pipes, and there are butterfly valves to maintain the one-way flow of the coal air mixture out of the coal carrier pipes. The mill base is provided with support, as well as there is arrangement to continuous recirculation of lubricating oil within the gearbox, as well as cooling arrangement through water cooling system. So this way the entire milling arrangement is made. Let us see the grinding arrangement within the bowl mill. The bowl actually fitted with bull ring segments, and these bull ring segments are fitted in such a way they are fixed within the bowl, and roll journal assemblies are there. And as coal is falling on the bowl, it is trying to get distributed across the bowl boundary, and while it is trying to go towards the boundary, coal comes in between roll journals and the bull ring segments, so it is getting pulverized. There are vane wheels which are supplying. Vane wheels are placed across the mill body surrounding the bowl, through which hot primary air is coming, and it is carrying the coal to the top of the mill body, and this coal along with primary air it is going to the classifier. Classifier is having classifier blades. These blades create the centrifugal force, and due to this centrifugal force, the heavier particles getting dropped again, recirculated back into the bowl, and smaller particles according to the fineness they are going through the discharge valve to the coal carrier pipe. So this way we see continuously there is recirculation of coal particles within the milling system, and finer coal particles going through the coal carrier pipes. Now coal feeding is done in such a way that there is continuous drying and pulverizing and carrying of coal across the coal carrier pipe. Naturally, if the drying is not proper, then coal will stick on the bull ring segment. So that's why according to the drying capacity coal is supplied, and that drying is ensured by the outlet mill temperature, coal outlet temperature from the mill, which is around 85 to 90 degrees centigrade. Primary air temperature, whatever we get at the inlet of the PS system, it goes up to 340 degrees centigrade. Beyond 340, if we try to increase it, then there may be more dry flue gas loss through the boiler. So naturally, we try to balance between the drying of coal with the degree of heat available within the PS system. Roller journal assemblies are made in such a way that there is a roller journal shaft. Journal shaft is fitted with lower journal housing and upper journal housing. There are two sets of bearings. Upper bearings are tapered roller bearing, double row tapered roller bearing, and lower bearing is angular contact roller bearings. Outside the lower journals, we have this grinding roll is fitted. It is actually shrunk fitted with some interference frit. There are arrangement to supply oil to the bearings through the centralized hole, and from this centralized hole oil is getting introduced in all the bearings for continuous lubrication. And there is sealing arrangement, there are sealing rings so that there is no ingress of coal dust within the bearings, or lubricating oil is getting contaminated with the coal dust. This way the entire roller journal assembly is fitted, and they are actually placed with the support of a trunnion, and with the from the top we have some spring loaded loading arrangement, and this spring loaded loading arrangement that helps in arrangement to give the necessary loading for your uh, uh, pulverizing. And this journal head can be tilted, and this tilting is provided to have a constant gap across the roller grinding roll zone and the bull ring segments. In general, we can move uh, uh, towards the center of the bowl or away from the bowl by adjustment of lock nut from the top and outside the your outside the mill body. And we have also arrangement to take care of your loading, and when there is more coal flow and wiring in the grinding roll, then we can tilt the entire roll journal assembly towards the bull ring segment. So this way we arrange the pulverizer bull ring segment setting so that maximum pulverized coal according to the desired fineness and quality can be obtained. Inside the scraper zone, we have two numbers of scrapers fitted with the vertical shaft through a bracket, and this scraper, one scraper is movable and another scraper is fixed type. There are side liners across the boundary. The air inlet chamber is there within the scraper zone, and there are guide vanes, and also we have insulation cover plates so that there is no heat loss across the scraper zone. There are reject spout through which whatever reject material are scrapped out, that can be dumped in the rejection chamber. So this way it has been arranged. The ball mill gearbox is having main three component: worm, shaft, worm wheel, and vertical shaft. Actually, worm shaft is attached to the worm wheel, and this worm wheel is fixed to the vertical shaft. The entire arrangement is placed in such a way it is properly lubricated. We have other three sets of bearings at the bottom of the worm wheel, and another two at the top of the worm wheel. So in the where bowl is fitted with the vertical shaft, we have key slotting arrangement to fix up the bowl with the vertical shaft, and below that we have scraper assembly that is fitted with the vertical shaft, and bottom of the scraper assembly we are having rolling contact bearings, and the bottom also thrust bearing is there, just on which vertical shaft is resting on the gearbox bottom housing. So this way the entire arrangement is there, and we have continuously rotating of the vertical shaft with the worm wheel, and worm wheel is rotated by worm shaft, and this worm shaft is attached with the motor, and naturally motor is rotating at high RPM, and that gearing ratio is there between worm and worm wheel. We have spiral scraper house in the scraper zone, through which any non-coal particles, heavier particles or big rocks, they are dumped from the scraper zone. There are arrangement to lubricate the bearings, and top bearings and bottom bearings, including thrust bearings. For that there is a small pump fitted at the bottom of the vertical shaft. This pump is fitted with the vertical shaft, and as it rotates along with the vertical shaft, it pumps the oil through a small hole across the vertical shaft for lubrication of the top bearings and intermediate bearings. From the top bearing there is a passage through which this lubricating oil passes through a lube oil flow side glass, through which continuously oil flow can be checked and monitored, and there is cooling arrangement of the entire lubricating oil supplied with the milling gearbox, and there is continuous water flow across it. For lubrication purpose, we use different kinds of lubrication oils. For gearbox, we use Servomesh 320, SP320 for worm wheel arrangement and bearings. For roll journal assembly, we use SP680. So this is the way of lubrication for this purpose. As you already know that we require sealing arrangement for pressurized milling system. Beside that, we require sealing of the roll journal assembly, so that lubricating oil supplied and bearings can be safeguarded from coal dust ingress within the roll journal bearings. For that, we have oil supply, and that oil is supplied to the roll journal shaft, going to the bottom of the roll journal bottom housing, and it is getting to the bearings, support bearings, and there are double row tapered roller bearing and the upper skirt, so that is also getting lubricated, and this entire lubrication is done with the lubricating oil supply from the outside of the mill. So we have a seal air supply system through a seal air fan, which is supplying sealing air to the roll journal assembly upper skirt joint of lubricating oil supply system to continuously seal the lubricating oil supply from the external coal dust and primary air dust laden arrangement. Beside that, at the vertical shaft, just below the scraper assembly, we have a seal air supply ring, and this bracket is supplying the sealing air at the scraper housing joint, so that coal dust cannot be ingress inside the gearbox. For mill rejects, in the scraper zone we have mill rejection spout, and in this spout whatever big boulders or non-coal particles are coming, those are being dumped, and from there it can be conveyed to the rejection disposal system. Let us now review the pulverized fuel discharge system. And inside the mill, for classification of coal according to size, we have classifier. Classifier is an arrangement where some blades are there, through which in the conical shaped part coal and air mixture is getting in, and due to this arrangement through the blades, there is a swirling effect. As a result of this swirling effect, the heavier particles are getting separated, and lighter particles, according to their fineness, they are moving up through the coal carrier pipes. And there is a continuous recirculation due to this presence of classifier within the milling system. There is a 3 to 5 times recirculation within the milling system, and so whatever coal is coming and whatever coal is moving out of the classifier, there is a continuous movement of 3 to 5 times across the classifier. Now there is a Venturi veins and collars, so that speed can be maintained through the coal carrier pipes, and we also try to have the equal velocity of distribution across the various elevations, so these venturi orifices are provided. Beside that, we can adjust the classifier bed angle setting, through which we can control the amount of recirculation within the milling system, and we can also adjust the opening at the bottom of the classifier through which recirculation is taking place. So degree of classification is also varied through it. Classifier mostly in smaller mills, they are static type of classifier. Nowadays dynamic classifiers are also introduced. In dynamic classifiers, classifier is actually rotating along with the vertical shaft, thereby improving the classification, and that improvement is done due to impact of rotation of the classifier in total along with the opening of the classifier blades. So this way we continue to pulverize the coal, dry the coal, and convey pneumatically the pulverized coal according to required fineness to the furnace. The MPS mills are higher capacity bowl mills. Only difference with the bowl mill is that in case of roll journal assembly, the roller journals are fitted with grinding elements which are wheel shaped instead of tapered shaped arrangement, and they are having capacity more than the bowl mill with roll journal assembly. But this kind of arrangement, this is more robust and having better grinding capacity, and they are
The other type
the
of
arrangement
vertical
to
spindle
introduce
mill of
dynamic
medium speed
classification
category
to
is
control
ball and
the
rest
fineness.
mill.
As the name suggests, here the grinding arrangement is made by grinding balls and rings, and these rings are, there are two rings, upper ring and lower ring, and this is just like ball bearings. As the lower ring is fixed with the mill yack, and this yack is connected to the vertical shaft, so the bottom race is rotating, and above that hollow grinding balls are placed, and these hollow grinding balls are again having a loading from the upper rings, which are again loaded through pneumatic loading cylinders from the external arrangement, and as the coal falls through the central feed pipe, it is falling on the yack, and this yack is rotating, so naturally coal tries to spread, and as a result of that they are falling within the grinding arrangement, and the pulverized coal is generated, and this coal is being carried by hot primary air supplied from the bottom, and which is getting inside through the passage between the mill body and the grinding race assembly So this is coming again to the top in the classified zone, and they are entering in the classified through the classified blades. There is a swirling effect. Heavier particles falls again in the back into the yak through the Honolulu skirt, and lighter particles according to fineness they are passing through the turret to the coal carrier pipe. So this way the ball and rest mill works. There is a gearbox, and this gearbox is attached with the vertical shaft to rotate the vertical shaft, and gearbox other end is attached to a motor 6.6 kV motor to supply the power for rotating the mill. The bitter mills or fan mills are impact type mills which are used for high moisture lignite or brown coal. This type of mills they utilize high speed milling. So due to impact whatever coal is dropped into the system, that is getting ground, and that is carried instantaneously with the hot medium through the mill outlet, and there it is getting calcified. Heavier particles returns to the feeding piping, and remaining is going through the classified zone and going through the coal carrier pipe. Here also we have velocity distribution arrangement, so that velocity is uniformly distributed across all the coal carrier pipes. So we have orifice nozzles, and we have one-way gate valves, so that there is no back pressure developed within the milling system. As a part of pulverizing, drying is a prerequisite, and if we cannot ensure drying, we cannot ensure generation of pulverized coal in powder form. We will get a paste. So naturally for drying we have hot air supply or flue gas supply as a drying medium, so that sufficient energy is available for drying the coal, demoisturizing the coal particles before they are turned into smaller particles and they can be pneumatically conveyed. Flue gas can be recirculated back from the boiler back end if necessary, but at the same time we have to see that the heat within the milling system must be in the air lean condition and fuel rich condition, otherwise there may be mill fire and explosion chances. So hot air supply is done in such a way that air is sufficient to dry the coal, at the same time there is no sufficient air to create fuel air rich condition, and there may be mill fire. Beside that we have to see the total coal air mixture which is passing from the milling system through the coal carrier pipe and going towards the burner. The velocity is within the control regime, so that there is no erosion taking place. Neither velocity is be too low, which can cause this chokage of the pipe, and that has to be avoided. So velocity within the coal carrier pipe is an important issue along with drying to maintain a proper pulverizing as well as carrying the coal for the purpose of burning within the furnace. Let us now discuss about the types of primary air supply system. There are various mechanisms to deliver the primary air depending upon the requirement of the air within the pulverizing system. Now, in pressurized cold primary air system, the primary air fans are drawing air from the atmosphere. Part of the air is passed through air preheater and some part is bypassed the air preheater. Two ducts are made. One is called cold PA header or cold PA bus, and another bus is called passing through the air preheater, the air coming to a hot PA bus, and through the damper, coupled damper, hot air and cold air is mixed within the final PA inlet to the milling system, We need this cold air for tempering the hot air temperature after passing through air preheater, because if mill temperature goes high, there may be chance of explosion within the milling system. Or if there is a flow requirement of air, hot air is more, we can reduce the cold PA supply, and by that we can increase the mill temperature at higher level, inlet temperature, so that for high moisture coal it is utilized. For ball tube mill, we find that cold PA, pressurized PA system is used, and from there hot primary air and cold primary air is mixed, and that air is fed to the pulverizer, ball tube mill. Along with that, we have hot air supply to the coal feeder inlet, so that there is sufficient pressure in the feeding line. We are also having some bypass air supply to the classifier zone, and this air supply facilitates the classification process and helps in maintaining the pressure within the total flow line. So this way we have arrangement of primary air supply at different zones of tube ball mill. The other type of primary air system is pressurized hot primary air system. In this case, the total air supply is controlled by FD fan, and from the discharge of the FD fan, part of the discharge is bypassing the air preheater, that is supplying cold air to the PA fan, and major part which is passing through the air preheater, it is bifurcated. Around 70% is used for secondary air purpose, which is going to the wind box, and around 30% mixing with the bypassed air of the air preheater, and this tempered air is entering in hot condition to the PFN inlet, and that is supplied in the mill. So here PFN is receiving hot air, and that is pre-mixed and balance adjusted depending upon the tempering requirement and utilized to the mill. In some of the units we find there is a suction type milling arrangement, so there is no primary air fan. In fact, they are having exhauster fan, which is creating a suction environment, negative pressure within the milling system. In this kind of arrangement, FD fan is drawing the total air. Some part is bypassing the air preheater, and major part is bifurcated, passing through the air preheater and bifurcated after passing through air preheater. Major part is going to the secondary air to the wind box, and some part is taken as hot air to the inlet of the milling system. It is tempered with cold air before air preheater, which is collected, and through a couple damper they are mixed up and sent to the mill. The outlet of the mill is connected to the exhauster fan, which is sucking the coal air mixture, and after that it is passing through the coal carrier pipes. There are venturi orifices and coal air distributor system, rifle elements through which they are distributed. So this is the end of familiarization of coal mills and milling system. There are different parts, how they are constructed, how they are working, and how they are utilized for supply of pulverized coal into the furnace and getting optimum heat release and generation of steam through that. If you have any queries, please contact me through email.